Well, number 4, as I look at number 4, it looks exactly like number 3. We have a limit as x approaches 2 of this fraction, this rational function. If we replace x with 2, we would see we'd get 0 over 0. But when we factor both the numerator and the denominator, we can see that the factors of x minus 2 cancel. And so then if we want to find the limit, we just replace the reduced version, in the reduced version with 2, replace x with 2, and we get 2 over 4, and so we get 1/2 as the limit as x approaches 2. So we know from our study in pre-calc, the pre-calc part of this class, that that would mean we have a hole, and the coordinates of the hole would be 2 comma 1/2. Okay, so the limit would exist there. Well, in this case here, as x approaches -2 from the right, we can see we already know we have a vertical asymptote because of our study in pre-calc, but we can see that we get -2 when we replace x with -2 in the numerator, we get -2. Replacing x with -2 in the denominator gives us 0, and so the question is it 0 from the right or 0 from the left? -2 from the right means -1, -1.9. That's going to make the denominator positive, so we get a limit of -infinity. And then likewise, replacing x with -2 from the left, we see that the numerator goes to -2 and the denominator goes to 0, but also from the left though, in this case, negative over a negative is a positive. So we get -infinity for the right hand limit, positive infinity for the left hand limit. And part C then, that's part B, that's part B, there's part A, I take it back. That there is part A, and this guy right here is part B, and part C says g of x is undefined at -2 and 2. Explain why the limit exists as x approaches 2, but it doesn't exist as x approaches -2. Well, the limit doesn't exist at -2 because the right and left hand limits don't agree. But the limit does exist at 2 because there's a hole. And there's a removable discontinuity. We can call it that. Removable discontinuity. And we know that when there's a removable discontinuity, or aka hole, then we have a limit existing. So the hole is at hole's at 2. Vertical asymptote at -2. We don't have a limit existing at a vertical asymptote. Okay, so that's it for number 4.